All right, class.
Yes.
Okay, so today is going to be a beautiful day in the neighborhood. We're going to do this. I'm going to show you how to do it on the calculator, and you guys are going to be like, man, that's so easy. I wish I could, do this all the time, okay? Be like, I got this. I feel good. I'm brushing my teeth. I'm thinking about how to put this in the calculator. I'm feeling it. I'm feeling good, okay? So, we're starting off with a different type of problem. So these are a half angle problem. Half angle problem. So it's not going to be much different. Just going to be a half angle. That's what is happening to my x value. On the previous problem that we were doing the homeworks, we had the x's by itself in parentheses. Today we have something else that's inside the parentheses with the x. So if I write this out, sine x over 2, close, equals 1. What do I know about all these? All these have to do what?
Equal to 0.
Equal to 0. Is this one currently, right now, equal to 0?
No.
Nope. What do I have to do to both sides? Very good. Subtract 1 to both sides. The golden rule in math says do unto one side as you do unto the other. So, is it not working very good? No. Try this one. There we go.
Thank you.
So, right here, we're going to end up with 2 sine x over 2 minus 1 equals 0. Now, my interval is going to be the next thing I'm looking at. So my interval has to do with my windows. And what does my answers have to be? My answers have to be in radian. But when I do this, I'm going to do this in what mode? I have to do it in degrees. So, for those people that missed the other day, my windows is going to be my x min. What's the x min in this case? 0. X max is what? 360, not 2 pi, right? 360, because I have to do this in degrees. And 2 pi is the same as saying 360. Y min? -2, that's standard. And Y max? Very good. Because I want to keep my answers right around the x-axis, so it's going to be really easy to see where it crosses the x-axis. Now, go ahead, put these in the calculator, and what's the one thing I have to do? I have to add to this to make it work on the calculator.
Degree symbol.
Add the degree symbol right here, because I always wanted to force my calculator in degrees. All right, I'm clearing my scratch pad so I can start from the beginning. Doc B. So please write that down. It's almost like, gotta say it all the time, clear the calculator, Doc B, especially when you pick it up for the first time. Okay, Doc B to clear it. And I have 2 sine, control, divide, because I'm setting up my fraction. Control divide, that's always going to be helpful there. I got x degrees over 2 over close minus 1. Is that correct? Minus 1? And we go through and change our windows. Menu, window zoom, settings, 0, 360, -2, and 2. Now, on this problem right here, how many solutions do I have? 2, right? Yes? Everyone has 2? Okay, so let's go through the steps to find it again. So step by step, so I know everyone's following through with this and finding these solutions. Menu. Analyze graph. 0. Alright, so lower bound. I'm going to click to the left of where it's crossing my x-axis. Hit enter. And now it changes to upper bound. Slide to the right. No, to the right. Okay. Cha-cha one time. Okay, anyway. So there's one of my solutions. And we're solving for x. That means that we're using zero product rule. That means my y value will always be 0 when I do this. So you don't have to write the ordered pair. You don't have to write the coordinate. You just have to give me the x value. Now let's do it again. Menu. Analyze. 0. So my 2 solutions are 60 and 300. 60 and 300. But how do I want my answers? In radian, right? Because at the very top it said that I want my answers in radian. So you could either find these on my unit circle or multiply by pi over 180. So on the unit circle, 60 is going to be pi over 3. And 300 is 5 pi over 3. There we go. Look, I circled it. It's done. Ah, sorry. There we go. All right. Woo, man, almost. I was worried because I was running out of black ink on there, so I was just worried. I had to go get some more.
You're such a silly guy.
You look like how when your parents had your clothes put on the bed.
That was a memeable face right there.
Hey. Never mind. No, keep going. Go away. Now she's gone. Yeah, we actually have a cool pass now. But no, don't tell her. She gets to carry the broom all the time. I'm sorry, was she talking some crap as she was walking out here a second ago?
You a silly dad.
Oh, is that what she said? I didn't hear her. She was mumbling.
That's what she said.
What did you think she said?
I don't know.
Silly guy. Silly dad.
Oh, hey. No one said anything about your mom.
What did you say about me, Angie?
Anyway. All right, so are we okay with this problem here? All right, let's keep going. Example 2. Now looking at example 2, what's different about example 2?
Oh, I like the broom, Poncho.
What's different about example 2?
Oh, it's another like cosine thing, right?
Yeah. Is it equal to 0?
No.
It's not equal to 0, so that's one thing I have to do, right? And again, this one is telling me I want my answers in radian. So I get cosine of 2x close equals cosine of x. Now, since it's not equal to 0, I gotta move everything to one side or the other. So what am I gonna do to the cosine x that's on the right hand side? Subtract it from both sides, right? Now, when we were doing the problem the other day, a lot of people try to combine like terms where there is not like terms. So when we were doing those problems, people are trying to combine a square with non-squares. So this is a double angle here, and this is a single angle. They're not the same thing, so I'm not combining them. And to make it even easier, make the calculator do all the work for you. Just put it next to it. So it's going to be cosine 2x minus cosine x equals 0. Does that make sense? So even if it was, you know, a cosine squared and a cosine squared or something like that, where you would combine, just put them next to each other, because on more than one occasion I've seen people getting, you know, was it 3 minus 4? Incorrect. So we could do all the trigonometry, but, you know, 3 minus 4, that caused some issues. Now, again, same window, but my answers have to be in radian when I'm done. So let's go ahead and do that. Oh, wait, don't forget, add your degrees.
Oh.
There you go. Add the degrees. So I'll show you how to change it without clearing out everything, but some people are on their phone instead, so you don't get this information. So I'm just going to hit tab, and it opens up a new one here, arrow up, and I can go control delete, will clear that for me. So the window's already set for me, right? The window stays. I could just change this. So we had cosine of 2x degrees close minus cosine of x degrees close, enter. Dang, that one looks weird. How many answers do we have? 3.
Oh, wait.
Huh? Yes. Okay. Does it look like there's an answer at 360? Is 360 one of my answers? Can I use 360? No, because that was outside of my interval. Remember, the interval has a parentheses right here. So that means it cannot be 360 in this case. So, but can it be 0?
Yeah.
Yeah, so let's check it for 0. So menu, window, right here, and change my x-min. What are we changing the x-min to?
-5.
-5. Let's do that. So all I have to do is move it over a little just so I can get my cursor to the left of this so I can check to see if 0 is an answer. So is 0 an answer? Yes, it is. Menu, analyze, 0. Menu, analyze, 0. There we go. So I do have 3 answers here.
That last one isn't 1.
What's not 1?
Like, it looks like it goes up on the graph just like 0.
Like, are you saying right here?
Yeah.
All right, let's go back to the interval. So,
Oh.
in my interval, this would be from
I see. I know what you
0, 360. 0 can be an answer, but 360 cannot be.
Okay.
So I could do like 359.9, right? All the way up to it, but not be 360. So 0, 120, 240. All right, either convert or find these on the unit circle. What is 0 degrees in radian? 0 pi, right? You can just put 0 or 0 pi, same thing. 120, 2 pi over 3. And 240, 4 pi over 3.
We should do notes like this every time. There's a lot more room.
Like what?
Like way more room.
More room?
Yeah,
Yeah.
just less
It's
ugly.
way better.
Okay.
Yeah, it looks
Okay.
kind of distracting to the eyes, so like less ugly.
Okay. Okay. Yeah. I thought I did them before, but it was just like a giant packet. I think it was like Unit 1. We had something like that, and no one really said anything. But I think that's been, no one remembered how to talk because you were back at school after a year of like just turning on your Teams and then going back to sleep. Yeah. So I swear, at the first month of school, no one really said much of anything. I think there was like a couple people that talked. That guy did.
Because I'm annoying.
Everyone just looked over.
Because I'm annoying.
No, you're not. You ask the good questions that people, are afraid to ask. All right, any other questions over this? All right, let's take a look at, do I want to do this one? No. Do I want to do this one?
Wait, we're not doing this one?
It's 4. Yeah, I was going to do 4, not 3. There we go.
I have no idea. Not this one?
It's the same thing.
Okay, but like for the radical one?
What about it?
Fine.
Oh, yeah, just, so all you're going to do is go minus radical 3, right? Radical 3. So it's 4 sine x degrees cosine of x degrees minus radical 3 equals 0. So it's the same steps.
Oh.
That's why. All right, so where am I at? I said example 4. Here we go. Again, on example 4, I'm skipping 3. My answers have to be in what mode? Answers have to be in radian. That's important. Now, I'm going to take a look at this. It says tangent 3x plus secant 3x equals 2. So is this one here equal to 0 yet? Nope. It's not equal to 0 yet, so therefore I need to subtract 2 from both sides.
Wait, where's that one at?
Example 4.
We don't have exactly what it is.
Yeah, they don't mark.
Yeah,
It's just the list of all of them.
Does it have it?
No, so look.
It's so black.
See?
Just.
It's just the equation, so we don't know which example it is.
It's in the
Either.
Oh, okay. I don't know. Find the one that looks like that. What?
You look so. You look so.
I didn't make the copy, so I'm like, oh no.
You sound like Mario when he drowns.
Wah. Anyway, minus 2 to both sides, right? So now I'm going to rewrite it. So it's tangent of 3x plus secant 3x minus 2 equals 0. And again, my interval is going to be 0, 360. All right, Fred, can 360 be one of my answers?
No.
Thank you. Can 0 be one of my answers? Yes. Let's go. So I hit tab, arrow up, and control delete will clear that. And it gave me tangent of 3x. And was it minus secant? Plus secant. Plus secant of 3x. Close minus 2. There we go. How many answers should I have?
4.
4? 3. So, if you notice, since I cleared off the previous one and it already had it set up, it sometimes comes up with, shows where the answer is already. It already shows you the 0. So it does it sometimes, not all the time. So if it does it for you, great. If it doesn't, you're going to have to find a 0. So like right here, it didn't find a 0 for me. Menu, analyze, 0. And so if we're going to round this to the 10th, which would be 1 decimal point, that's going to be at 12.3. Right there. So my solution is going to be 12.3 degrees. What's the next one? And so these ones definitely are not on my unit circle.
Are you sure?
Quite possibly. So when we do this, how do I plug it in to actually get this answer? Like the 12.3, how do I convert that? Multiply by pi over 180. So let's look. We have 12.3 over 1 times pi over 180. So it's going to look something like this. 12.3 pi over 180. And if you recall, what do I do with the pi? Slap it on the end, right? So it doesn't look like it cleans up very well, right? No, it doesn't. So all these right here are most likely going to come out to be weird decimals. So we take it and we multiply by pi. Where's my pi button? I know, but I can't. I don't think I could get to my. There you go. There you go. So we multiply it out, and it's going to give me a decimal. So I'm going to say 0.2147. So this solution is yeah, you don't add the pi on this. And then do it again for this next one.
When you're done, can you go to the calculator again?
Do what?
Go to the calculator again?
Back to the calculator?
Yeah, just go for it.
There we go. What's up?
So, how are you getting all the decimals? Did you show me those?
We set this the other day. We went document settings.
Are you gonna be really stickler about like what we round the decimals to?
Yeah, why not? All right, what's the next one? What was the next one we got? After the 0.2147? Say it again. 09, like that?
Yeah.
Okay, and you got the last one?
4.403.
4.403. Now, there is a... Come on. Running out of ink again. All right. So there is a symbol for radian. You notice that there's a symbol for degree here? You won't see it very often, but I wanted to show you that if you want to tell the difference in between, it's a little R where the degree symbol would go. All right? So that's going to signify that this answer here is in radian. I'm not going to be a stickler about that. I'm not going to be a stickler about the decimal very much. But if you only use one place value, this one would be to 0, right? This one would be 2, and this one would be 4. It's going to be a very, very different answer. The least amount of zeros that you use. So that's why I'm saying use, 3 or 4 decimals. I'm not too much of a stickler on it. Just use a couple. You have it on the calculator. The calculator did everything. At least, write down what the calculator tells you. All right, that's it. So let's go ahead, like, share, and subscribe. Hit that notification button and use promo code I need to pass to get 10% off.